Video yesterday. I think we were only able to get about 2 or 3 minutes in, so I will start that video again today and we'll go from there. Okay, that'll make it look a little more clear.
Are the other gals on slides like us too?
They're a little bit ahead of you, but not much.
Discover freedom.
The notion of driving while black reminds us that that's not available to all Americans to be able to live.
Just an ad, hold on. Here it is.
But what could cause comets to fly in from the furthest edges of the solar system, slam into Earth, and deliver these organic compounds? The clues to one possible process lie back out in the Kuiper Belt, the disk of icy objects that orbits the Sun at the edge of our solar system.
We expected when we found the Kuiper Belt that we would just see objects in nice circular orbits about the Sun.
But observations revealed that the Kuiper Belt objects are not orbiting as predicted. Out here, it's chaotic.
When we look at the Kuiper Belt, we see something that looks like somebody took the solar system, picked it up, and shook it real hard. And that's what started us thinking that something really strange is happening.
Levison theorizes that the reason for this mayhem likely is connected with the two largest planets in the solar system. Jupiter is so big it could swallow more than 1,300 Earths. And Saturn, with its vast rings of ice, is 95 times Earth's mass. With their enormous size comes an enormous gravitational pull.
Everything that we see is a result of what Jupiter and Saturn did.
Levison wonders if the chaos of the Kuiper Belt could have resulted from a planet smashing into it. To find out, he runs a number of computer simulations. One model creates the conditions in the Kuiper Belt that we see today. 3.9 billion years ago, as Jupiter circled the Sun twice, Saturn made one complete orbit. Each time these orbits coincided, there was a powerful gravitational surge. That pushed Saturn's orbit further from the Sun and destabilized the orbits of the two outermost planets, Uranus and Neptune.
Jupiter and Saturn sort of tugged each other, and that drove the orbits of Uranus and Neptune absolutely nuts.
Uranus and Neptune are sent careening outwards towards the Kuiper Belt. Comets ranging in size from a mile across to objects the size of Pluto are blasted out of their orbits by the planetary invasion.
The disk went kaboom. Think of it as sort of a bowling ball hitting bowling pins. These things got scattered all over the place.
The end result is a 100-million-year period when comets, kicked out into the solar system by Uranus and Neptune, smash into anything in their path. It's a period scientists call the Late Heavy Bombardment. Earth doesn't escape.
so violent that probably every square inch of the surface of the Earth was hit by a comet during this time.
This is one theory that might explain how massive amounts of organic molecules, the building blocks of life, made their way to Earth. Possible evidence of the late heavy bombardment can be seen on the surface of other planets and moons in the solar system. Impact craters.
Literally, the seeds of life, the amino acids, would have been delivered to all the planets and their moons in our solar system.
So if life's building blocks were delivered by comets throughout the solar system, could life also have sprung up on worlds other than Earth?
Hypothesis 1, organic monomers from space. We find organic chemicals in old meteorites discovered even today, such as this one. It is estimated that several million kilograms of organic chemicals fall as cosmic dust to Earth each year. Two scientists, Oparin and Halliday, proposed in the 1920s that organic chemicals that form the basis of all life could evolve in Earth's early atmosphere. Hypothesis 2, organic monomers from reactions in the shallow ocean. In 1953, Stanley Miller used Oparin and Haldane's original ideas and tested a hypothesis involving an artificial mixture of inorganic molecules while simulating the conditions thought to be found on primitive Earth. Here's an explanation of how he did that.
But how did chemicals like these get into the first living things? Nobody had a clue until a young college student did a brilliant experiment which would transform our understanding of the origin of life. Stanley Miller and his teacher Harold Urey had the bright idea of recreating the chemical mix and environment of the infant Earth in miniature. Using apparatus like this, reconstructed here at Sussex University, Miller was about to try some chemistry that hadn't been seen on Earth for nearly 4 billion years.
This is the equipment that Stanley Miller devised to recreate the early Earth's atmosphere.
Miller surmised that the early Earth's atmosphere was an unbreathable mix of the gases hydrogen, methane and ammonia.
The small flask of boiling water represents the sea. As the sea evaporates, a mixture of gases is introduced. The gases dissolve in the steam, and the whole lot enters this chamber here.
And it's in here that the really interesting chemistry happens. These sparks recreate the electrical storms thought to have been ravaging the Earth all those years ago. And it's this bolt of energy that makes the steam and gases in here react together in unpredictable ways.
After getting this big kick of energy, the gas and steam enters the condenser. And here the steam is turned back into water, falls as rain, and is carried back into the sea.
This cycle of boiling, sparking and condensing was repeated again and again, just as it would have on the ancient Earth. And then something strange started to appear in the bottom of the equipment.
After a week of continual sparking, Miller found that he created an orangey red sludge.
But this was no ordinary sludge. Under the chemical conditions he thought occurred on the Earth billions of years ago, Miller had created some of the stuff of life.
Crucially, he had succeeded in creating amino acids.
Amino acids are crucial chemicals because they are the building blocks of proteins. And proteins are what the bodies of living things are made of. Without amino acids, there could be no proteins. and without proteins, there could be no life. While Miller had succeeded in creating some of the stuff of life, science had no idea how such chemicals were assembled to make living things. This remained a tantalizing mystery. One which would be solved when two of the most famous names in the history of science made an astonishing announcement. Their discovery revolutionized biology and would, at long last, put science on the path to the origin of life.
Okay. All right, now the next few slides basically break down step by step how he did this experiment. Okay, so he's got, here's a bottle or a container of seawater, and then he's added heat to that, which is going to cause water vapor. Oops, is this one? Okay, then your atmospheric compartment, okay, so the water vapor is going to go up through here, and then you've got your water, your nitrogen, hydrogen, ammonia, carbon dioxide, chlorohydrin, carbon and hydrogen, and then they're going to add electricity to that, which is going to simulate what lightning would have been like. And then there's a condenser here, so the lightning goes through, and then there's a condenser which cools off that water, which cools it there, and then it condenses back into liquid. So the ocean is sampled and its composition is analyzed. So once it goes through this whole process, then they test it when it comes back to here. And then they found those organic monomers once they went through this entire process. Subsequent work found some defects in Miller's work, but have produced, with experiments, that took into account new information about early Earth, most of the naturally occurring organic molecules, and validating Miller's hypothesis. The organic molecules found amino acids, which are the building blocks of proteins, sugars, lipids, and nucleotides.